Hi friends, now in this session we'll revise reading number 2, organizing, visualizing and describing data. This reading is very basic reading and relates to descriptive statistics. So first part of the reading is basic terminologies required for the descriptive statistics, and the second part is a basic concept related to the descriptive statistics. So basic terminologies like what is a numerical data versus categorical data and so on. And then in the basic concepts we will discuss mean, mode, median, standard deviation, like the measures of central tendency, measures of variance, skewness, kurtosis and everything. Now because this is a revision session, I will assume you know at least the basics of it, because I will focus more on exam orientation of this chapter instead of discussing each and every detail here. Right, so let's start with the first. The basic concepts. Okay, now first the numerical versus categorical data. So numerical data is simply the numbers data, also known as the quantitative data. So simply the numbers. For example, student score in the examination. So this is the numerical data. On the other hand, we have got categorical data. Categorical data is the qualitative data and which is used to classify or group the items in your data. So for example, pass, fail, male, female. So all these are the categories. So this type of data is the categorical data. Categorical data is also known as the qualitative data. These are the points you need to remember, very basic discussion. Then we have the time series data versus the cross-sectional data. Now in time series data, you plot time on one axis and then your variable on the another axis, the like y-axis. Okay, so x-axis time, y-axis your data. Now here the example, the simplest example is stock prices. Stock prices collected for a month. Okay, stock price movement for a month. So this is example of time series data. So to say it simply, so time series data is the set of observations taken periodically. Okay, so you will collect observations periodically. On the other hand, when it comes to the cross-sectional data, so you collect data at a specific point in time, but remember in the cross-sectional data you will need two variables. For example, students number of hours prepared for the exam and exam score. So this is the cross-sectional data, right? So you will plot, say, number of hours prepared on the x-axis and exam score on the y-axis, and then you will plot the point. So this is the cross-sectional data. Then we have the panel data. Panel data is the combination of time series data and the cross-sectional data, important statement for your exam. Then structured data versus unstructured data. So structured data simply is the time series or the panel data or the cross-sectional data. So all these data are the structured data. And on the other hand, unstructured data is in unstructured format. For example, the reviews on Amazon is the unstructured, because you can't directly use that and do the statistical analysis, right? So you have to convert unstructured data into structured data to do the statistical analysis. So the unstructured data is from the perspective of statistical analysis. So for exam, you have to just remember unstructured data is in the unstructured format. That's it. Now, the data can be organized into arrays. Arrays simply means like you take student score and you collect all the students' exam score, and this exam score is the array. So you can have the unidimensional array or simply the array, or you can have the two-dimensional, one-dimensional, multi-dimensional array. So as you add more variables, so to give the example, so name of the student, roll number, student score in the exam, or pass or fail result. So now you have multi-dimensional arrays because you have different variables here. Then we have the frequency and related distribution. So mainly here we have the frequency distribution discussion. Again, this is a very fifth standard level discussion. So again, the frequency distribution is simply the distribution of frequencies. So you have data and you create bins like the ranges. So from 0 to 5, 5 to 10, 10 to 15, 15 to 20 and so on. And then you will calculate how many observations lie within each bin or each range. And then from this you create a frequency distribution. Now in frequency distribution you have the absolute frequency distribution or you can also have the relative frequency distribution. Now the absolute frequency distribution is the actual numbers, okay, actual number of observations lying in that particular bin or in the range. On the other hand, relative frequency distribution is simply the percentage of observations out of total observations. So percentage of observations in that particular bin. So simple, the absolute frequency versus relative frequency. Relative frequency is in the percentage format. Absolute frequency is in the simply the number of numbers format. Now you can have normal absolute or relative frequency, or you can also have the cumulative absolute or cumulative relative. Cumulative means simply as you move from one bin to next bin, you will add all the previous bin's values. So same is applicable for the absolute frequency and also applicable for the relative frequency. So I guess just a second. Now this is the example from CFA's curriculum book. Now just see here. So this is the market of country A, B, C, D and so on till M. I guess it's still R. And then we have the index return for the specific country. Now it starts with the 7.7% and so on. So here you have all the index returns. Now the first thing you have to do to create a frequency distribution is first order your observations. Okay, so we will order returns. So from lowest to highest, that is in the ascending order. And once you have this, we will decide the bin. So here we are creating a bin like so 5 to 6%, 6 to 7%, 7 to 8%, 8 to 9% and so on. And once you have the bin, you will put the values here. Okay, so now see. So return bin is 5 to 6%. Now we have to measure how many values are in between 5 to 6%. So it is 5.5%. That's it. So here we have absolute frequency only 1. If you consider 6 to 7%, in 6 to 7% we have 1, 2, 3, 4. So here we have 4 values. So absolute frequency is 4, like this. And this is how we have the total observations. Total number of observations are 18 in this particular case. So here, if you total this, like the absolute frequency 1 plus 4 plus 6 plus 4 plus 3, you will get the answer 18. Now the relative frequency is simply 1 divided by here. It is in the percentage format, percentage of total observations. So here 1 divided by 18 is 5.56%. That's why the relative frequency is 5.56% for the first bin, 5 to 6%. If you consider say 7 to 8, here we have total number of observations equal to 6. In this case, the relative frequency is 33.33% and so on for the others. Then we have the cumulative absolute frequency. So here we will keep adding the previous observation. So if you just consider say bin number 2, so 6 to 7%, here we have cumulative absolute frequency is 5. How are we getting this answer? So 4 plus 1. So if you simply take say 8 to 9, so the relative cumulative absolute frequency is 15. So how are we getting this answer? So 4 plus 6 plus 4 plus 1. So previous value, simply add the previous values. Okay, then cumulative relative frequency, same principle is applicable here. You will simply add back the previous values. So here, if you just consider the second bin, so this is 27.78%. How are we getting this answer? So it is 22.22 plus 5.56%. And this is all about the frequency distribution. Okay. Now, for exam purpose, so steps in the frequency, first you will define intervals, then observation tally. Again, this is 5th standard discussion, how to do the tally and all you already understand. And then we have the count the observations and you will get the absolute frequency. Then you can calculate the relative frequency using the absolute frequency, and then you can also have the cumulative absolute frequency and cumulative relative frequency. Okay, now data can be cumulative absolute, yeah, we already discussed this. Then we have the contingency table. Now contingency table is a 2-dimensional array where we have 2 dimensions obviously. So here this is the example of 2-dimensional array, and example is very simple. Now, so level of technical writing expertise is on the in the rows, whatever it is. Okay, so horizontally, and major like the stream is in the vertical. Okay, so STEM, social science, humanities, interdisciplinary, and then level of technical expertise or writing expertise required or have for these candidates is like, first here we have none, no technical writing expertise. In this STEM there are 8 students. So this is the joint value, joint observation or joint frequency for no technical expertise and in this STEM. Similarly, the technical writing expertise, or I'll simply say it as writing expertise. So expert level writing expertise, it's 39 for STEM, and if you take the interdisciplinary stream, then it is 14 expert. Okay, so this is again joint frequency. Okay, so this is a joint frequency table, shows the frequency of the 2 variables simultaneously. So here we are getting the 2 variables simultaneously. Now marginal frequency. Marginal frequency is simply the value of each or either of the level of the technical writing expertise or stream. For example, if someone asks you what is the marginal frequency of STEM students, so you have to simply take the total 8 plus 7 plus 11 plus 39, and whatever is the answer, you will get this as a STEM. So it is simply the total numbers in STEM or total numbers in social science or total number in beginners. Okay, so technical writing expertise beginners level. If you get the question on the marginal frequency, then simply always remember the marginal frequency here means the total frequency. So you have to simply take the total of the beginners. So 7 plus 41 plus 11 plus 9, and whatever is the answer, you will get the answer for marginal frequency of technical writing expertise at a beginner level. Then you have confusion matrix. So confusion matrix is 2 into 2 or 2 cross 2 matrix, which shows the occurrence, predicted and actual number of observations. So here we have the example of confusion matrix. Now in this we have some predictions and we have the actual results. Here I took the example of cricket match. So say in upcoming World WCC or simply the World Cup. So India is going to play, this is just the assumption. So India is going to play say 50 matches. Now India versus say Sri Lanka, India versus Australia, India versus maybe Pakistan, India versus and other countries. Okay, and this is how we have say 50 matches. For in front of at the time of prediction. So right now say World Cup is not yet started. So at the in front of every match we will write, okay, what is our expectation, what is our prediction? So will India win or lose? So we will keep writing it as win, win, lose, win, win, and so on. Okay, and we will fill the table. So we will have our prediction. In prediction, we will have here, say this is the predicted yes. Predicted yes means predicted wins for Indian team. Okay. Now here the predicted yes wins is 35. So out of the 50, 35 India will win and 15 India will lose. So that's our prediction. But when a match starts, okay, when the actual World Cup will start, we will actually see, okay, what was our prediction and what happened. So say our prediction was India will win, and now in actual match also India won. Now here, this will be the predicted yes, that is a predicted win, and actual yes also. So actual win. Okay, so predicted win and actual win. But say if we predicted India will win, but in reality India lost the match. Okay, so in that case we will mention it here. And similarly, say out of total predicted wins, India won 25 and lost 10 matches, and this is how we get this setup. Okay, and the total predicted wins were 35, 10 and 25. In the predicted no, here we have 12 and 3. So actual, so we predicted no. Now understand what is this. So predicted no means India will lose these matches. So this was our prediction. But out of these predictions, so out of these 15s, India won 12. So that's why we have predicted no, but actual yes. So predicted loss or but actual wins. And here predicted no, actual no. So we predicted India will lose, and in reality also India lost. So this is how we got 12 and 3. So this is how you calculate it or create a confusion matrix. So here, so predicted yes 35, predicted no 15, actual yes, that is actual wins 37, and actual no 13. Okay, this gives us the power of prediction. Okay, now data visualization. So here we have the histogram, frequency polygon. Histogram is simply the absolute frequency distribution. Okay, so you can see this. This is the histogram. Just a second. So this is the histogram here. See this? Okay, so all these bars are the part of histogram, and then frequency polygon. So you can see there is a line connecting the middle points of these bars. So this is the frequency polygon. Okay, frequency polygon is again used for the same purpose, but it connects the midpoint of interval. Now the cumulative frequency distribution, if you cumulate this, you will get a cumulative frequency distribution. Then we have the bar chart. Bar charts are simply, again, these are histograms are also bar chart because there are bars. But bar chart is simply it shows the relative size or value, and it can be vertical or horizontal. Now it can be the simple normal bar chart or group bar chart. Like here we have the group bar chart, and this is data of quarterly results for these 4 companies. Revenue results, okay, and in the Q1 of 2020, so for the 4 companies, what happened in the Q2, what happened in the Q3 and Q4, okay, so you can compare the result of these companies. Okay, so this is a grouped, okay, grouped according to quarter. Now then we have the stacked bar chart. Stacked bar chart as in, instead of grouping like this, you will stack it, okay, on one another. Then we have the tree map. So this is the tree map. Tree map provides you the relative size of the category, and this is the Indian market index. Okay, so all the indexes are represented here. Now, line and dual line charts. So simply the stock prices, that is time series charts, are line charts because it represents in the line. And you can also have the dual line if you are comparing, say, or if you have say 2 stocks to compare, then it will be the dual line chart. Bubble line chart as in the line plus bubble. So bubble is the size of a second dimension. So first on the x-axis you have time, on the y-axis you have stock prices, and the bubbles will represent maybe say EPS of each year. If you are taking say past 10 years analysis, if you are doing the past 10 years analysis and you want the EPS of the company and the share price also, so you can combine it like this. So the size of the bubble will be, the bubble line will show the bubbles plus line, and the bubbles will show the EPS. So I'm just adding the example of dimension. So it will add the dimension, bubble will add the dimension. Then we have the scatter plot. Scatter plot is used in the cross-sectional data. So where you have two variables, as I said, students number of hours spent in preparation of CFA level 1 exam versus the student score in the examination, assuming we get to know these scores. So we will use the scatter plot for this. And again, because it's a revision session, I'm not showing you each and everything. Then heat map uses the color indication to display the frequency. And this is the example of heat map. Now this is the very important part for your exam. So choice of plot. So if you want to show the relationship, and this is, you must remember this, if you want to show the relationship between the two variables, then you have options, which is scatter plot and a heat map. So see here, so here we have one dimension, and then we have that is one variable, then we have the second variable, and we are showing the relationship here. So this is very general or the common example used in the data science or the data analysis. This is a petals analysis. Okay, so petals length versus width and so on. So this is the for the relation. Then if you want to compare, okay, so showing relationship is different, and then comparison is like the revenue of two companies is the comparison. So here we have options which we can use. So we can use the bar, tree, heat map for the categorical data or the categories. Remember, bar, trees, and heat map. So how bar? So for example, we have two companies. So two companies will form the category, right? So that's why we can use the bar here. Then tree and heat map. So all the options are open. And line, dual scale, bubble line chart for the time series data. Okay. Then for the distributions, if you want to plot the distribution, then we have the options: histogram, frequency polygon, and cumulative distribution chart for numerical data. And then bar chart, tree map, and heat map for the categorical data. Okay. And then we have the word cloud for the text analysis to see the frequency of the text. Okay. Now, coming to our core discussion. Now, the core area, as I said, descriptive statistics. So here we will mainly see 4 discussions. So first is the measure of central tendency. So how data is centered. Then measure of dispersion. How data is scattered. What is this variance or standard deviation? Then what is the skewness in data, and what is the kurtosis, or simply or also excess kurtosis. Okay. Now, starting with the measures of central tendency. So here we have 3 primary measures. So first is the mean, mode, median. So first is the mean, second is the mode, and then median. Mean, mode, median. So we'll discuss mean later. First the mode. Mode means where the observation which has the highest frequency. Okay, so highest frequency. Okay, the number which is repeated maximum time in your data is the mode of the data. Then we have the median, and the median is central number or central value. Okay, the value in the center after ordering the data. You can have the ascending order, the descending order. Generally we say after ordering the data in the ascending order, and then find the central value. So here the simple thing is, if you have even data, then you won't get the exact center. So you will get the 2 values in the center. So you simply take the average of those 2 values. Very simple. And again, I'm not discussing this in detail because again, this is very basic stuff, and really very basic for a CFA level students, and we all know how to deal with this, and that's why I'm avoiding it. If you have the odd data, then you will have the exact central value, and that's why. So you will get the median, so you don't need to take the average here. If you have the odd number of observations, if you have the even number of observations, then take the average of central to value, because you don't have the central value, you don't have the single value in the center. Okay, again this is in after ordering the data. Now in mean, we have different types of mean. First is the simplest arithmetic mean, then weighted mean, then we have harmonic mean, or say geometric mean, and then we have harmonic mean. Okay, so arithmetic mean can be used in almost all the cases. So weighted average mean is, or geometric mean or the harmonic mean is used in the specific cases when there is a requirement of a special type. Okay, now arithmetic mean, we all understand how to calculate the arithmetic mean. So arithmetic mean, for example, say we have observations, say 3, 5, 7. So for the calculation of arithmetic mean, we will do the calculation like 3 plus 5 plus 7. Again, I know you understand this. I just want to put it into the formula. That's why I'm using this or doing this. So simply solve the answer and you will get the arithmetic mean. Now, formula is summation of xi divided by n, and also x bar is equal to summation of xi divided by n. And this formula is for the population and this formula is for the sample. No relevance for your exam, because whatever the data you have, you will use the same formula, the same technique. It is just how the formula is noted. Okay, so the notation used for the population mean is mu, and for the sample mean is x bar. Then we have the weighted average mean, mainly used if, so for say example, you are doing the analysis of the portfolio, you have say 3 stocks, and say stock A, B, C, return of the stock in percentage 3%, 5% and 7%, and weight of the stock in the portfolio, say weight is 0.25, so 25%. So out of $100 invested, $25 are invested in the stock A, say $50 invested in stock B, and again 25 invested in stock C. So here to calculate the mean, we will use the weighing scheme. So the answer is simply the average return is equal to 0.25 multiplied by 3 plus 0.50 multiplied by 5 and 0.25 multiplied by 7. And whatever is the answer, this will be your weighted mean. Now remember, arithmetic mean is also weighted mean, but here weights are equal. Okay, so all the weights are equal. So you can, again, if you want to put same format in the arithmetic mean, you can put it like this. So here our weight is 1/3, right? So we will put weight of 1/3 for each value. So 0.3333 multiplied by 3 plus 0.3333 multiplied by 5 plus 0.333 multiplied by 7. Okay, you will get exactly same answer, and both have the same format. The only difference, not the technical difference, academic difference you can say, in the weighted mean and the arithmetic mean is, in arithmetic mean we will have the equal weights, and because we have the equal weights, you can use the simple formula here. And in the weighted average mean, you will have different weights, okay, for your values. Similar format, the weighted mean can also be used when there are probabilities. So instead of say weight, you can have the probability, and probability. So probability of stock return will be 3%, say 0.25%, stock return will be 5%, say 0.50%, and stock return will be 7%, say 0.25%. So you have probabilities here, you have returns, same formula, same method, but now we can also use it for probabilities. Okay, so probability or weight. Now then we have the geometric mean. Now geometric mean is used for the calculation of return of multiple periods. Okay, multiple periods, and the formula is just write formula here. One plus R is equal to root n, 1 plus R1, 1 plus R2, so on, 1 plus Rn. Now, for example, you have, say, you're provided with the information of portfolios written for the first year, second year, and third year, and you want to calculate the geometric mean or the mean in this particular case, the mean return. So we can use this formula. And here, because we have the periodic returns, okay, and the period, the first period influences the second period, and second period influences third period. So we need a geometric mean. So geometric mean is a better measure. You can use arithmetic mean for the as an exam shortcut, but geometric mean is the proper method, and you have to remember for the exam that geometric mean is used for the calculation of the return. So to calculate the average return for the stock or the portfolio for the of multiple periods. Okay. Now here, for again, we will take the same example. We'll use these values only 3%, 7%, and 3%, 5%, and 7%. And so you have these 3 years. So in first year, stock produced 3% return. Then in second year, it produced say 5%. In third year, it produced 7%. So what is the average return produced by the stock? Average annual return produced by the stock. So here, what we will do? So 1 plus R is equal to, because we have 3 years, so it is 1 plus 3%, 0.03, 1 plus 0.05, and 1 plus 0.07. Simple. Okay. So 1 plus 0.03, 1 plus 0.05, 1 plus 0.07, and simply now multiply it and calculate the answer. 1.03 multiplied by 1.05 multiplied by 1.07. What is the answer? Y to the power x, bracket open, 1 divided by 3, bracket close, and you got the answer. Okay. So 1 plus R is equal to 1.04987, and simply this plus 1 will get into the minus 1, and you will have the answer 0.04987. And you can simply use it in, or say it like so, 4.987%. If you do the simple calculation, you apply arithmetic mean in this particular case, that is 3 plus 5 plus 7 divided by 3, so you will get 5%. 5%. So in exam you will get answers very close. But for example, like say you don't have time in your exam and you are asked to calculate the geometric mean. So my recommendation would be to calculate arithmetic mean and select value which is slightly below your arithmetic mean. And this is again in case of urgency, you don't have, say, assuming you don't have enough time in your exam, and in that case, if you want to apply, you can calculate geometric mean using the arithmetic mean. Okay, because difference is very less between the two, but geometric mean is more accurate and used in the specific case of the returns of multiple periods. So to calculate the average return of multiple period. Okay. Then we have the harmonic mean. Now, assume you decided to invest in a stock, and instead of investing all of your funds in just first month, so you have $300 to invest, and you have decided to invest $100 in each month. So in month 1 you invest $100, in month 2 you invest again $100, in month 3 you again invest $100, and in the month 1 the stock price was say 5, in month 2 stock price was 8, in month 3 stock price was 10. Now we want to calculate what is the average purchase price of this stock in this particular case. So average purchase price, Now to calculate average purchase price, obviously we will need how many number of stocks we have and how much money we have invested. Simple. Okay. And once we have this, we can simply calculate the average purchase price. So here, number of stocks purchased number of stocks purchased is equal to 100 divided by 5, 20, 100 divided by 8, 12.5, and 100 divided by 10, 10. So total number of stocks purchased 20 plus 12.5 plus 10, 42.5. Now we invested total amount of $300, and total number of stocks we are able to purchase is 42.5. And if you simply 42.5, and if you simply solve this, 300 divided by 42.5, so answer is 7.0588. Okay, so this is how you can calculate the average purchase price. Okay, now do we have any shortcut? So yes, we have, and the shortcut's name is calculation of the harmonic mean. Now in the harmonic mean, we do the calculation like so. N as in the total number of purchases, or here we have the total number of instances. So 3 months, here we will have 3, and 1 divided by purchase price simply. So 1 divided by purchase price of first month, 1 divided by purchase price of second month, plus 1 divided by purchase price of third month. And here in N we will have 3 because we have 3 months. And simply solve the answer. So 5 1 by x, store it in 1, 8 1 by x, store it in 2, 10 1 by x, store it in 3, recall 1 plus recall 2 plus recall 3, whatever is the answer, 1 by x, you have to reciprocate it and multiply by 3, and the answer is 7.0588. So exactly same answer. Okay, now this is the illustration given in your curriculum or the books or the notes. Now this gives the impression that we can use the harmonic mean formula only and only if we are investing the same amount in each month, but this is not the case. I will tell you like how you can tweak the same setup to get the answer for any investment value. Okay, now I will give you example by simply changing one value, and then you can do the trial and error for yourself. So I'll say instead of in month 3, instead of investing $100, I'll invest $200. Now see what happens, like how, what will be the first total number of shares, and first we will calculate average purchase price here, okay, in the normal setup. So here, if you invest $200, so obviously we will have 20 shares, and this will give us 20 plus 20 plus 12.5, total number of shares purchased 52.50. Now here average purchase price will be $400 because we invested total 400. So 100 in first month, 100 in second month, and 200 in the third month. Total 400 divided by 52.50. So 400 divided by 52.50 is equal to 7.6190. Now, how to tweak this formula? So tweaking is very simple. Simply calculate, it's 100 plus 100 plus 400. So we have, say, in saying, we can say we have 4 instances instead of 3. So let's say 4. And here, because in month 3, we are investing twice the value. It is double value, right? So we will write 2 here. Simple. And then we will solve the answer. So 2 divided by 10. STO3, because in storage 1, memory 1, memory 2, we already have our 1 by 5 and 1 by 8. So I simply change the third value only. Now the recall 1 plus recall 2 plus recall 3, whatever is the answer, take 1 by x and multiply it by 4. And magic, we have this value, exactly same value. Okay, 7.6190. So this is how you can use the harmonic mean. Now again, I will complicate the example. And you have this as homework if you have time, so don't waste your time. I'm just giving the elaborate explanation in case you get this in your exam. So say in month 1 you are investing 100, in month 2 you are investing 200, in month 3 you are investing 300, and you are asked to calculate the average purchase price of the share in this particular case, and you are provided with the share price in the each month, the purchase price in the each month. So here what we will do simply, so 1 divided by 5, that is $100 invested. We are saying it like $100 invested at the rate of 5, $200 invested at the rate of 8, and $300 invested at the rate of 10. And how many dollars are invested? $500. So simply write it as 5, and that's it. Now solve this and you will get the answer. Very simple. Okay. So very simple and straightforward formula for the calculation of just a second, for the calculation of average purchase price, right? Now, coming back to our arithmetic mean. So arithmetic mean considers all the values, and generally arithmetic mean is impacted by the outliers. Okay. It's impacted by the outliers. So outliers are, say, too high or too low, it will unnecessarily pull your arithmetic mean or the mean to one direction. So general method is to adjust these outliers. So I can give the example, very simple. So say there are like people are reviewing, there are panel of judges, and those who review movies going for the Oscars, and then they decide which movie should win the Oscar based on the points given to that movie. So here, say you have to, and you are the judge, and you have to rank movie 0 to 100. Now we know like the movies are made on various social subjects, political matters, so there are different things in the movies, and this might influence the judges or the reviewers' opinion. If say a favorite actor is working in that movie, the reviewer might end up giving full points. Sorry for that. Okay, or some reviewer might give 0 rating because they hate that say actor in the movie. Now these extreme values, or say outliers, will influence the average rating for that movie. So what we should do, we should eliminate these outliers, and there are two methods to eliminate the outlier. First is trimming, and second is Winsorized mean. Okay, now here in trimming, what we do, we simply cut, or we don't consider the values beyond our interval. For example, say we are calculating mean using 95% values, so 2.5% higher values and 2.5% lower values we will simply drop. We won't consider these values. This is in case of the trimmed mean. Okay. On the other hand, when you are calculating or when you are doing the treatment of Winsorized mean, so what we will do, all the values above this point, and say this point is 90 and this point is say 10. So above these values, we will consider these as 90 only. So we will replace all the values above 90, assuming these are the 2.5% higher values. So we will replace them with the 90 instead of say some value is 95. So we won't consider 95, we will treat it as 90 only. And here also we will do the same. So if the value is say 0, we will treat it as 10. We will replace the value as 10. So same value will be replaced in both the sides. And this is how the Winsorized mean works. Again, for the exam purpose, remember Winsorized mean is a better representation because it captures the impact of outliers but reduces the impact of outliers. Okay, so this is how Winsorized mean works, and that's why it is considered as a better treatment to outlier while calculating mean compared to your trim mean. Okay, fine. Now next discussion is quantiles. Quantile simply means dividing your data into equal number, or say in equal percentage. Okay, so you'll divide your data into parts, but the percentage should be same. Now here, first we have quartile, then quantile, decile and percentile. Not very important for your exam, I think, but it is good to know. Okay, now you will divide data into 4 parts using 3 cutoff points. Then here just see how, first of all, like how to divide data into 4 parts using 3 cutoff points. So assume this is your data. First cutoff point, second cutoff point, third cutoff point. In quartile, this is at 25%. So here we have 25% data, here we have 25% data, again 25% data, and again 25% data. And this is how you get the 100% data. So first cutoff point is at 25%, then second cutoff point is at 58%, 50%, and then we have it at like 75%. Okay, these are our 3 cutoff points, and and after you get the 3 cutoff points, your data is automatically divided into 4 parts. Okay, remember, just for your information, this range, that is the difference between the 25% value. Remember, this is percentage. This percentage is indicating the percentage of data observations. Value will be different. Say the 25% cutoff point is maybe 15. Here maybe 45. Here maybe like 86. So here, so difference between the 25% cutoff and 75% cutoff is known as the IQR, interquartile range, and this 50th percent cutoff is your median. Okay. Okay. So similarly, like your quantile, decile, and percentile. So in quantile, you divide data into 5 parts. In decile, you divide it into 10 parts. Again, cutoff point will be 1 less. So 9 cutoff points for decile, and in percentile, it is 100 parts, but using 99 cutoff points. Okay, all these points will be like equal in percentage. Equal as in, like, it will represent the data in the bins will be equal. Fine. So this is about the calculation. This is about the quantile, IQR, and median. You have to remember this. Then we have box whisker plot. Box whisker plot. So this is very simple. Now, say this is your plot, and in the plot we have box like this. Okay. Now, so this is the graphical representation of your quartile. So this value is, say, 75th percent value. This value is 25th percent value. This value is 50% value. So here in this range, we have 25% observations. Here we have 25% observations. Here we have 25% observations. Here we have 25% observations. And this is the highest value, and this is the lowest value. Okay. So line cutting this box is the median, and this is your IQR. Okay, so this is what you need to remember. And just to give you the value, so what is our value? So it's 15, 45, 86. 15, 45, 86. 86. And say highest value is 99 and lowest value is 0. And this is how your box fixer will look. Okay. Now the measures of dispersion. Measures of dispersion is how data is distributed or scattered. Simple. If I had to give you the example, So which data is scattered more? I say this plot is X and this plot is Y. Obviously, we can see the Y is more scattered, more dispersion, more variation in the data is available in the Y. But we need the quantitative measure. So we need something like some formulas to calculate the dispersion. So to calculate dispersion, we have different methods available, and the method starts from, first is the range. Then second method is IQR. We already saw IQR. I'll just tell you what is range. Then we use standard deviation or variance. Then we have the relative dispersion. And then we have the variations of standard deviation, which is mean absolute deviation or downside deviation. Okay, so we'll start with the range. So highest value and the lowest value in the observation is simply the range. So range is also the measure of dispersion. So say there are two classes, class 1 and class 2. So highest value or highest marks scored in the class 1 by a student is say 86 and lowest score is say 46. So here you will get the range, calculate the range, and then say in class 2 it is 96 and 26. So where do we have the highest variation in the data? Using the range measure. So we will say we have highest measure here. Okay. Then in case of interquartile range, IQR, we already know, like we will use the cutoff point 75% and 25%. We will calculate the difference. Whatever is the difference, it will be the IQR, interquartile range. Now we have the standard deviation and variance. Now to give you the example, like to understand the standard deviation and the formula, I'll just take this simple stock price movement. Okay. And let's say this is point A, B, C, and D. And this is your X bar, average. Okay. So in variation or variance, we are simply calculating this distance. Simple. That's it. That's all. Okay. And because we are calculating this distance or this difference, like how the other values are different from the mean, we use the formula. And the formula goes like, let's say this is your X. These values obviously are X, right? So X minus X bar, we will square it, summation divided by N and then under root. And this is the formula for variance. Okay. And sorry, this is the formula for variance. Now, the standard deviation is under root of variance. Standard deviation is denoted by sigma also. And then the formula here is X minus X bar square divided by N. This is a very simple formula. Again, if you want to, you can remember the formula, but you can directly use the calculator. So in calculator, we have this stat function. Okay. So second data. So here you can feed your X values, and after you feed the values, instead of using this formula, you can directly get the answer from the calculator. So calculator will give the standard deviation of population, standard deviation of sample, and so on. So generally you don't need to use this formula in your exam, because anyway you can use the calculator for this. And calculation is really lengthy, and obviously you can't, like in 1.5 minutes for each question, obviously you can't apply the standard deviation formula for that particular question, right? So not possible. So this is the formula of standard deviation. So standard deviation is denoted by sigma, and that's why variance is denoted by sigma square. So because standard deviation is sigma, simply the variance is square of standard deviation. That's why sigma square. Okay. And this is for population. For population. Now, what about sample? So in sample standard deviation. Okay. So sample standard deviation is denoted by simply the SD, and population standard deviation is denoted by the sigma. Remember this. It's calculated as summation of X minus X bar square. Everything is same except for in denominator we will use n minus 1, and this is what we call it as a degrees of freedom. So we have say n minus 1 degrees of freedom in case of the standard deviation, and that's why we use n-1. So there are reasons available for using n-1, but generally in academic books we say like okay, so using n is biased measure of variance for the population. That's why we take n-1 in the denominator to make our variance formula, the standard deviation formula, unbiased. This is, remember, this is also unbiased measure of population variance. Okay, and if you use this formula, this is the biased variation. Okay, biased measure of population variance. Fine. Now this is about the basic setup, the basic formula and everything. Now let's see it with the data so that you get the proper understanding, and then using this we will be able to understand MAD and downside deviation also. Okay, mean absolute deviation, the downside deviation. Okay, now see this. So this is the standard deviation, and these are the values of for x: 100, 120, 150, 170, 200, and 140. No, just a second. 148 is mean. Okay, so only these are the values. Now see here, our formula is x minus x bar. So obviously first we will need the x bar, and this is your x bar. Okay, so simply take the total and divide it by 5 and you will get the x bar. Now our formula is x minus x bar. X minus divided by n. Okay, so formula is not looking very appropriate, so the root is complete. Okay, so remember, root is for whole term and not just for this. Okay, now see, so what we need here? So x minus x bar, obviously first we will need the x bar, so here we did the calculation of x bar. Now x minus x bar, and here we also need square. Okay, so x minus x bar. So here we did the calculation x minus x bar and we got the x minus x bar, the difference between the x and the x bar, and this is also known as the mean deviation. Okay, so this is the mean deviation, x minus x bar. Now the problem with the x minus x bar is, like, once you have x minus x bar, because the distance from the mean or the sum of the difference for all the mean is same. Okay, so this, just a second, one more correction is required. Okay, so okay, now the distance from the mean, if you consider the sum of distance from the mean of all the observations, so you will get the answer 0. Okay, and which you can see here. So if you simply take the total of these values, the x minus x bar, all the differences between the x and the x bar, the answer is 0. At this particular point, our calculation stops. We become helpless. So statisticians derived some different methods to treat this problem, and one of the treatment or one of the method to solve this problem of getting 0. See, once you have difference 0, you can't do anything, right? So that's why we take the square of this. Remember, squaring here is only done, we are squaring this x minus x bar only to remove these negative signs. Okay, so minus minus and all the plus. So once you take this square, once you have this square, now we can sum it up. Okay, sum of squared mean deviation. Okay, once you have this, divided by n, total number of values, and then take the square root, and this is how you get this standard deviation. Very simple calculation. Remember, this is the point. Okay, from this point we went with this. Now when you square it, we call this as standard deviation. So standard deviation is the squaring method, that is squaring your sum differences, mean deviation, to get the answer, to proceed further. Obviously there is also one more solution, maybe you are able to think it. like why not to simply ignore the values, these like values as sorry, why not to simply ignore these signs, the positive and the negative signs, and simply assume all these are the positive signs and solve your answer? Yes, totally possible. And we call this as MAD, mean absolute deviation. So here in mean absolute deviation, we simply ignore, or we simply take the absolute value, that is 48, 28, 2, 22 and 52, then add it and then divide it by 4. Okay, so here we have 5 observations. We are calculating standard deviation assuming sample, and that's why we are taking n minus 1 here. Okay, n minus 1. Fine. So 48 plus 28 plus 2 plus 22 plus 5 is 152. 152 divided by 4, and your standard deviation. So no, MAD, not standard deviation. So MAD, mean absolute deviation, is 28. Okay, so this is how you get the second methodology. Okay, and why are we not taking under root here? Because we never squared the values. Why we are taking under root here? Because we squared these values unnecessarily, not unnecessarily, by ourselves, right? So we pushed values into squares. So that's why we are taking the under root to get back our values. Okay, now downside deviation, also known as the targeted deviation. Now in downside deviation, this is same as standard deviation, but instead of taking x minus x bar, you will decide your target. Okay, so this is to compare, mainly used in this portfolio analysis and all. Say our acceptable return is say 10%, and we want to see or consider impact of only returns where we had below 10% returns. Okay, so here in this case, our target return is, what is the target return? Just a second. 160. Okay, so this is our target. See here, target is 160. So we will calculate the difference from 160. So 160, whatever is below 160. Okay, and that's how you get only negative values in your calculation, and that's why we call this as a downside deviation. So you will take the negative values. Again, we will apply same principle as standard deviation. We will square these values. After squaring it, we will calculate our sum, and then calculate the, again, this is not the standard deviation, this is downside deviation. Okay. So this is downside deviation is 36 and standard deviation is 31. This is your standard deviation. Okay, so these are the 3 concepts in the dispersion. Then we also have the concept of coefficient of variation, CV. Okay, that is a relative dispersion. So this is very simple. This is the standard deviation of x divided by mean, or simply sigma x divided by mean of x. Let's assume the standard deviation is 15 and mean is say 5. So your CV is 3. Simple. So what are we doing here? So this is the coefficient of variation. So it simply means what is the deviation in proportion to mean. Okay, so if the mean is higher, obviously our deviation should be higher, right? So deviation will be higher or more likely to be higher. So let's say there are 2 stocks, stock A and stock B, and we did the calculation, and stock A's current price S0 is 50 and stock B's current price is 5,000. Then mean price, average price of, in the say past 1 year for the stock A is say 40, and standard deviation of price is say 15. Then just a second, 25, let's say 15, and then here, so it is 4,500 and standard deviation is 1,500. Now tell me, which stock has higher standard deviation? If you just compare this, you will end up assuming like this particular stock, the stock B, has a higher standard deviation, so maybe the stock is more risky. But this will be problematic because see, this standard deviation is in relation to the mean of 4,500. On the other hand, in case of the stock A, the 15 standard deviation is in comparison or is in relation is related to the mean of 25. And that's why we need to calculate, or we should calculate, the CV, coefficient of variation. And coefficient of variation for this stock A is calculated as 15 divided by 25, whatever is the answer. And coefficient of variation for the B is calculated as 1500 divided by 4500. And let's see, 15 divided by 25, answer is 0.60. And 1500 divided by 4500 is 0.333. So coefficient of variation is lower here. Okay, so we can consider like this is better, like low risk stock compared to the A. Okay, so like this. So this is about your dispersions. Then we have discussion related to the skewness and kurtosis. Now there's a problem in explaining skewness and the kurtosis without explaining the distributions, but still we'll try. Now understand this. In statistics, normality of this stock is very important. Assume this is normally distributed stock, 50% here, 50% here. So 50% from the right of the mean or the center, and 50% from the left of the center. Now here, one thing we need to understand, the normality, normal distribution, the normality of the observation of the data set is very important. If the data is not normal, we can't use a lot of tools available in the descriptive statistics, and that's why we need to measure the non-normalities existence in the data. So we check, or we use tools like the skewness and the kurtosis. Okay, skewness and kurtosis. So skewness is third moment and kurtosis is fourth moment. Variance is second moment and mean is the first moment of the data. Okay, now let's ignore, like here I will ignore the skewness formula of the skewness. If you want, check your book and remember it. In my opinion, you can't like do the calculation of skewness in your examination, but you should know like this is third moment. Now here there is a possibility, like first the data is normally distributed. If the data is normally distributed, then the skewness in the data is 0. But it is possible that there are outliers in the data which is pulling the data's this distribution's right side. Okay, if this is happening, then outliers on the right side, and this is positive skewness in the data. So this is a positively skewed data, and the skewness will be higher than 0. Okay, maybe say 2. So this is positively skewed data. Similarly, we can also have the negatively skewed data like this. So outliers on the negative side. Outliers in the negative side. Okay. And this is negatively skewed data. And skewness will be less than 0, maybe say -1, like this. Now here, for exam, you must remember the mean, mode, median's impact based on skewness. If the data is positively skewed, then remember this is mode. Obviously from the distribution only we can understand the mode. This is the mode and this is the mean. Okay, so mode and mean, because we have outlier on the positive side, so mean will be pulled here, and in between we will have median. Okay, so in positively skewed distribution or the data, so mode will be lowest, then median, then mean. Okay, so mode is less than median is less than mean. In negatively skewed data, here we will have our mean, here we will have our mode, and here we will have our median. Okay, and in negatively skewed data, your mean will be less than mode will be less than, sorry, mean will be less than median will be less than mode, like this. And this relationship is very important for your exam, please remember. Okay, and highly testable in my opinion. Then we have kurtosis. Now this is about the skewness, and this is a third moment. Okay, so you will have this negative impact and positive impact. And again, if you want a detailed discussion on this, I have my videos are already available on the YouTube related to the FRM. So just check for the, I guess, random variable video on this topic in FRM, or the basic statistics video. And in that video, I've already discussed all these things, okay, in detail. If you want the details, formulas, why are we seeing skewness like this and like this, and all the explanations are given there. Not very important for your exam. Then we have the kurtosis. So kurtosis tells us about the pickedness in the data. Okay, so this is leptokurtic. This is known as the leptokurtic. Red is platykurtic, and this is mesokurtic. Okay, simple. Now this black line or the distribution is normal distribution. Black is a normal distribution. Remember this, black is normal distribution which has kurtosis of 3. Normal distribution has a kurtosis of 3. Leptokurtic has higher kurtosis more than 3, greater than 3, and this has the fat tails and peaks. Remember, fat tails and peaks. Fat tails you can see here in leptokurtic, fat tails, see this. Okay, so tails are fatter than the normal distribution, and peak is also higher. So here we have the peak. Just I have this. Okay, so these are tails. So see this difference, and then this is the peak. Okay, can you see, like the peak is higher. Similarly, then we have platykurtic, and platykurtic will have kurtosis less than 3. That is thin tails and less peak, compared to, remember, both are compared to normal distribution. Okay, normal distribution. So very simple discussion. Again, this is the fourth moment. You have to calculate. You give power of 4 in the calculation. Remember, you give power of 4 in the calculation. In skewness, you give power of 3 in the calculation. In variance, you give power of 2 in the calculation. This is the power of 2. In the mean, you give power of 1. So that's why the first moment is mean, second moment is variance, power of 2, third moment is skewness, power of 3, and then kurtosis, power of 4. Okay. Now see here, which is the fourth moment, kurtosis. Now this is about the kurtosis. But the problem is, like, the skewness is 0 and more than 0 and less than 0 in this particular format, and kurtosis is 3 for normal and then less than 3 and more than 3. So this was creating confusion at like very long back, and that's why we got the concept of excess kurtosis. Okay, excess kurtosis. So that for the normal distribution, just see, like for the normal distribution, skewness is 0, kurtosis is 3. Why not to have alternate measure so that we can have the 0, 0, minus, minus, plus, plus, like this. So excess kurtosis is simply the kurtosis minus 3. So excess kurtosis. So here, excess kurtosis for normal distribution will be 0. Now this is in parity. And for leptokurtic distribution, we will have positive excess kurtosis. So positive excess kurtosis, similar to the skewness. But remember, it indicates, skewness indicates the outliers on the left side or the right side. On the other hand, kurtosis tells you the probability in the tail. Okay, so higher tail or the fatter tail means higher probability in the tail. Thinner tail means lower probability in the tail. Okay, higher peak means higher probability in the center, like this. and for bradycardic it will be negative like this. Okay, so excess kurtosis. So kurtosis and excess kurtosis. Remember, excess kurtosis is just kind of a, in India terms we call this as a jugaad. Okay, jugaad to have things like the skewness. Okay, skewness 0, positive, negative, and kurtosis positive, negative. Okay, then we have the concept of covariance. We discussed variance, now the covariance. Now the covariance is very simple. In variance, if I break down the formula of variance, I will write the formula like so. Just first the normal formula. Okay. If I break down this formula, so instead of writing x minus x bar square, I can write it as x minus x bar and x minus x bar again like this. Okay. Now this is the formula of variance. So in variance, we calculate the movement with itself. Okay, I'm just saying this to explain the covariance, but we calculate the movement of the variable with itself. But what if we have two variables and we want to check the co-movement of two variables? Maybe we are analyzing a portfolio and there is a co-movement. Co-movement means how the combined movement of two stocks work. So in this case, we'll need covariance. And just like if you say the variance is for xx, covariance is for xy, and simply use the formula or simply change the formula for the calculation of the covariance. So variance is for the xx, covariance is for the xy. So what will happen here? So summation of x minus x bar, y minus y bar, y minus y bar. Simple. And now you will get your covariance. Now covariance have no interpretation. Covariance is in simple terms is the combined variance. Combined variance, right? Now here we need some concrete measure, the understandable measure. If I provide you simply the covariance of particular say two variables x and y, so covariance of x and y, remember variance is with one variable, covariance is with two variables. So if I provide you the covariance, it is not highly interpretable. So we go with the correlation of xy, and correlation of xy requires the formula of the covariance of xy. And to calculate the correlation of xy, we simply take the covariance of xy divided by sigma x and sigma y. In exam, if you get the value, simply take the value of covariance, simply take the value of sigma x and simply take the value of sigma y, and you will get the answer. Remember, the range of correlation coefficient is -1 to +1. So lowest value possible for the correlation is -1 and highest value possible for the correlation is +1. Now -1 means perfect negative correlation, means if the stock price of stock A increases, stock B is decreasing, and if the stock B is increasing, stock A is decreasing. If this is happening, there is a negative correlation between the two, we will say this as a, so maybe this has the -1 correlation. -1 is a perfect negative correlation. Then +1 is the perfect positive correlation, means if the x increases, y increases, if the x decreases, y decreases. So both have the same movement. Okay, and then we can also have zero correlation. If this is the case, the correlation is 0, then we will say this as no correlation between the x and y, but the better term to say it as no linear correlation. No linear correlation. There may be non-linear relationship, but a linear relationship or linear correlation is not present between the x and y, but there may exist a non-linear correlation. Okay, so there are two types of correlation, the linear correlation, and this correlation is also known as the Pearson's correlation. Pearson's correlation coefficient. The formula used here is for the Pearson's correlation coefficient is the linear correlation measure. Okay, and there are also non-linear, there are also paired correlation measures. Fine. Now, what is the indication of -1 and +1? This is my justification. Like, why can't correlation move above +1 or -1? And there is also a formula for the beta. Okay. In beta, we will discuss the beta part when the beta comes. Okay, but for now, just one thing. So beta is calculated as. Okay. Now see. Correlation of xy multiplied by sigma x divided by sigma y is the formula for the beta. And beta also shows the relationship and correlation also shows the relationship. For correlation, there is range, -1 to +1. But for beta, there is no range. Okay, so beta can be anything depending on what are the values. Now, what is the meaning of this? Why do we need two relationships? Remember, correlation provides you the answer of the movement between the two variables. If the correlation is +1, this means every time x increases, so y increases, and every time x decreases, y decreases. If say we have 100 observations, in all 100 cases, whenever x increased, y increased, and x decreased, y decreased, so they both had the same movement of increase or decrease. This means this is the +1 correlationship, the 100% match in the movement. I call like this, so it is better for the understanding. So if someone asks you like why correlation can't be more than 1, because 1 + 1 indicates the 100% match of the movement. So how can you have 1.2 correlationship? How can there be a 120% match? Maximum it can be 100% match. Okay. Now, why -1 is the bottom limit? Because again, you have 100 observations, and in all the 100 observations, they had the opposite movement. So every time x increased, y decreased. If x decreased, y increased. And this happened in all 100 observations. This means there is 100% negative relationship between the two. So 100% or 100 times it happened. So that's why it is -1. So how can there be a more than -100% or say more than 100% in negative side relationship? Not possible. That's why there is a limit of -1 and +1. Now the question is, if x increased by 10%, what will be the impact on y? If x increased by 10%, by how many percentages y will increase? And this answer is not provided by the correlationship. Remember this. And this answer is provided by the beta. Provided by beta. And that's why beta measure is used in a lot of statistical scenarios or even the finance. Very famous tool in analysis. Okay. Then we have properties. We already discussed the properties. Then we have the scatter plot to show the scatter plot to show the relationship in correlations format. So if we plot the correlation, so this is the x variable, this is the y variable, and these are the points. If this is how the data is moving, then this is the positive correlation. If this is the scenario, then this is the negative correlation. That is, see, x is increasing, y is increasing, positive correlation. When x is increasing, y is decreasing, this is the negative correlation. Okay. So this is how you analyze it. If the data is like this, we can't draw any line here. X is here, y is here. It is not conclusive. Okay. So you can't have you can't say this is a positive correlation or negative correlation. Okay. So this we will say it has no correlation. So how to provide it on scatter plot, or how it will look on scatter plot, like this. And then there is also non-linear relationship. A non-linear relationship works like this. Now see here, this is non-linear relationship. There is relationship available, but our correlation measure, which is a Pearson's correlation measure, is only capable of analyzing the straight or linear relationship, and hence it won't be able to capture this curvature's impact, and that's why you may end up getting, in this particular case, it is visible, like there is a relationship, but if you use the Pearson's correlation here, maybe you won't get any linear or substantial linear relationship between the correlation between the x and y. And this is the point you have to remember. Like, what is the meaning of correlation is equal to 0? So this means the linear relationship is 0, but it has no impact or whatsoever. Like, you can't conclude that there is absolutely no correlation between the two variables. There may be existence of the non-linear correlation between the two variables, like I've shown here. Then there is also spurious correlation. Okay, so spurious correlation, and also we have the concept of okay. So two variables are showing relationship between the two, but ultimately like there is a third variable which is impacting these two variables, and that's why you are able to figure out the relationship. For example, so my height increased, like since the day I born, my height increased or kept increasing, okay? And say my parents measured height of mine, and similarly we also had a tree, very small tree, at the same time I was born, and that tree's height also grew. Now if you compare this, like you will end up concluding like there is a, if you simply use the statistical measure, the statistical measure will show that there is a correlation between the my heights increase and the tree's height increase, but there is a common variable impacting our heights, which is a time. Obviously our heights will increase, so this is the kind of spurious correlation. So maybe correlation is visible, you are able to see the correlation, but there is no actual underlying reason behind it, okay? So there is no cause, okay? So correlation is not causality, this is how we say it, and that's what you need to understand here. Correlation, spurious correlation means the correlation is visible, it is there, but it is wrong. There is no correlation between the two. Okay, so that's all about our revision. If you have any queries, you can ask in the comment section and I will help you with the doubts. And also you can WhatsApp me on this number which is 909613168 for your doubts. And also there is a mentorship session going on for FAB exam. Only I'm taking like maximum 10-15 students. So if you need a mentorship, please contact. Okay, thank you very much. Thank you for watching this video. See you in the next video. Bye bye. Take care.